In this chapter, we look at supply chain integration. And the reason why supply chain integration is important is because you have several components in the supply chain that has to be coordinated in order to ensure that the supply chain performance objectives can be met. Typically, we want to reduce costs, we want to improve service levels, we want to reduce the bullwhip effect, we want to make better use of resources, and of course, we want to be able to respond to changes in customer demands. So, in order to make the supply chain efficient, we are left with little choice but to attempt to sort of coordinate activities across the entire supply chain. To be able to do that, we can meet some of the challenges that occur on the demand side, which actually pulls inventory through the supply chain. But at the same time, which is where customer demand comes in, sorry. But at the same time, we also want to look at the back end of the supply chain where we're actually supplying, we're producing, and we want to try to find ways to optimize production and manufacturing in the supply chain. So if you look at supply chains historically, they tended to be the push or pull systems. And by a push system, we often talked about the idea that you would sort of make to stock. So you push, it would be based on long-term forecasts, and then the supplier will sort of determine what's the optimum production strategy and push supply to the retailers. A pull system is a reversal of that, which basically would say instead of simply having stockpiles of inventory, why don't we match production to the actual demand? And so an order is only triggered when a demand is received, and therefore you pull inventory through the supply chain according to the actual demands that occur. Those two strategies, while they both have their advantages and disadvantages, often require sort of a hybrid, somewhere in between, where if you look at the entire supply chain, that part of the chain needs to be push and part of the chain needs to be pull. And then the question becomes, where in the supply chain would you actually locate what we call the push-pull boundary? All right. So in manufacturing systems, you tend to find, as I say, this sort of traditional push and pull system. So now we want to focus on the hybrid strategy of push-pull. And so where do you actually locate the push-pull boundary? Let's just try to understand a little bit more about push-based versus pull-based systems, and then look at the hybrid strategy. So typically what would happen is that, as I said, you have long-term forecasts. The manufacturer would try to predict the orders and then manufacture with respect to that, and then make to stock, and then attempt to push that inventory down towards the retailer. All right. In a case like that, this kind of a system is not very effective in responding to customer demand. You tended to have fairly large levels of inventory. The risk of obsolescence was actually increased. Variability in terms of orders were also causing the bullwhip effect. And so while you might have gotten economies of scale, and usually manufacturers want that because of the high capital cost of running the facility, it is not necessarily the best strategy in terms of minimizing inventory-related costs, or minimizing the impact of variability or the risk of obsolescence and so on. All right, so the variability in the orders tended to cause, as we see here, excessive inventories due to the need for large safety stocks, larger than and more variable production batches, and then the service levels were not necessarily the best, because if all of a sudden you had a major change in demand and you ran out of stock, then that manufacturing facility, because it's trying to get economies of scale, would take a long time to actually meet that demand, because it's more concerned about being cost efficient than actually being responsive. Okay. Now, in push-based systems, we talk about the concept of a bullwhip effect. And part of the reason why you would have this bullwhip effect fairly prevalent is because each stage of the supply chain is attempting to determine or forecast based on the pattern of orders received from the downstream customer. So a distribution center is trying to forecast based on what retailer has been ordering, not necessarily what the demand is. A wholesaler is doing the same thing based on what the distributor is ordering, and then the manufacturer is forecasting based on what the wholesaler has been ordering. In that case, the bullwhip effect is fairly strong, and it's not clear to the manufacturer how to optimize production capacity, transportation capacity. Should it be based on what they perceive to be the average demand or the peak demand, and so forth? All right. So often what happens is that you get higher transportation costs, higher inventory levels, more emergency production changeovers because shortages are incurred, and so the system needs to be examined so that it can be optimized for performance. In pull-based supply chains, however, production and distribution demand-driven. What it means is that the demand actually determines what is actually produced or what is actually distributed. So once you have the true customer demand rather than a forecasted demand, then you service the orders. In a case like that, that system tends to be a bit more responsive. It typically has lower levels of inventory and it reduces the effect, the bullwhip effect. And so as a result, it's fairly attractive because you tend to reduce the lead times. Because you're operating on an actual demand, then you're better able to anticipate incoming orders. You reduce the inventory necessary, reduce variability, and then you could reduce inventory in the upstream part of the supply chain. So one would tend to think that we would just implement pull-based systems, but pull-based systems can be a little difficult to implement when you have fairly long lead times. Because just imagine if a customer is expecting an item to be shipped, within a day. If you have a pull-based system that with a long lead time, say of 5 or 6 or 7 days, then just triggering production when the demand actually occurs will not allow you to meet those service levels because the manufacturer needs 7 days to produce the item, but your customer is expecting it to be shipped in 1 day. The way in which you would have solved that is if you had stock at the distribution center or at the manufacturer, where the only thing that impacts the lead time is the actual transportation lead time. All right. Well, you have a little bit of transaction processing and so on, but you don't have to wait on the manufacturing lead time. So, as we said, both push and pull systems have the advantages and disadvantages. However, there's a need for a hybrid, and that hybrid is what we call a push-pull strategy. So what that means is that some parts of the supply chain can be operated as a push system, and then the other parts can be operated as a pull system. So the point at which you have the inventory is actually stocked, and there's buffer inventory between the two stages, that's where you have what we call the push-pull boundary. So if it is at the distributor, for example, well, you will have stockpiles of inventory at the distributor, but inventory is not shipped to the retailer until a demand actually occurs. So that means the push-pull boundary is at the distribution center, or it could be done at the wholesaler or at the manufacturer itself. So it all depends on the nature of the environment within which that supply chain exists. Okay. So here's just a sort of a diagram of that push-pull boundary, where the bottom part towards the customer would be pulled, and then top part would be pushed, and so forth. So as you say, the general strategy in this case is to make part of the product to stock, and then you could have some point of differentiation later on. So I did mention the example of Sportable Maya, where the ski jackets, because they could come in various sizes, various colors, various designs, however, there's some generic fabric that is used in all of them, then you could make the stock at the point just before the demand is received, and that would be a push, and then pull when the demand is actually received, So you need a very responsive manufacturer, somebody that could react very quickly to that demand and then put the jacket together to meet the actual orders that has happened. All right. So those things, how you make the decision in terms of where that push-pull boundary is very crucial. So let us take a look at what is the appropriate strategy depending on what the expectations are. So if we have an environment where demand is highly uncertain and we also are interested in the economies of scale, then what happens? What are our choices? So we could create these sort of four quadrants, and it sort of gives us a sense of different types of strategies. So let's look at this. So here we want the economies of scale. We go from low to high, and demand uncertainty, we go from low to high. So if we think about books, let's look at this quadrant right here. No, actually, before we look at this quadrant, let's look over here. When demand is highly uncertain, the demand is highly uncertain, and there's really no need for economies of scale. That means because economies of scale makes you want to produce large batches. So if there's really no incentive for economies of scale and demand is highly uncertain, you wouldn't stockpile a whole bunch of inventory because the risk of obsolescence is too high, the risk of stockout is too high, or maybe the risk of excess inventory can be very high. So in a case like that, you would have a pull system. When you receive the order, that's when you trigger the production, and that's why Dell made great use of this concept right here. So an example of that would be a computer environment where there's really not a lot of need for economies of scale, but demand is highly uncertain. So a lot of electronics items actually fall in that category. Let's go across the diagonal to grocery stores. Well, a grocery store, because it's a penny, it's a very low margin business. You want economies of scale. So typically, the grocery store is not going to order 2 cartons of milk. It's going to order a large shipment so it could get really, really low prices and then turn around and try to maximize the margin on that product. So the need for economies of scale is very high. However, unless you have promotions and so on, the demand uncertainty is fairly stable. I mean, the cans of milk, how is that going to change? Or rice and so forth, or even meat and poultry. So these things are not going to change drastically unless you have a season like a Christmas or Easter and so on, where certain items have some seasonal effects. But generally speaking, the demand for these items on a day-to-day basis or week-to-week basis is fairly stable. So here you would have uncertainties very low, and the need for economies of scale is very high. So when uncertainty is low, it's okay to actually maximize or to go for push system, because your forecast of your demands will be fairly accurate and you wouldn't have to worry too much about either stockouts or stocking excess inventory. However, in terms of economies of scale, since you need that also encourages the production of large quantities or the storing of large quantities. So here you would have a push system, and grocery stores are a fairly good example of that. Now let's go across this diagonal. This is where we see the need for push-pull sort of strategy, where in this case here, the demand uncertainty for books doesn't really spike. They're fairly stable, CDs and so on. That's fairly low. However, there's really very little opportunity for economies of scale. So because the demand is low, you would say, let's push. Let's actually do a push strategy. But the push strategy is such that there's no real incentive for economies of scale. Stockpiling CDs. CDs are fairly cheap to ship. And so as a result of that, you could, because of low demand uncertainty, it's suggesting a push system, but because of low opportunities for economies of scale, it is suggesting a pull system. So when somebody needs a CD, then you could sort of trigger dispatching from the distribution center and so forth. All right. Now the manufacturer might want economies of scale in terms of manufacturing those items, but when we're talking about the point of distribution between the distributor and the retailer and so on, or even just the retailer and the customer, then you really don't see the need for a push system here to stockpile tons of books and tons of CDs and so forth. All right. Same thing here with furniture. The demand is highly uncertain, and you do want economies of scale. Now, economies of scale, because of again the equipment that's used in production of furniture is fairly expensive, so you like to be able to take your costs and spread them. However, while that suggests a push system, the demand uncertainty does not recommend a push system. It recommends a pull system. So when you have the orders, that's when you actually ship. So at some point, you will need to kind of have a push-pull boundary somewhere in that supply chain where part of it is pull. Perhaps the customer pulls the demand, but pulls it out of a warehouse. And so the push-pull boundary is somewhere either at the wholesaler or the distribution center, but not stockpile at the retailer. Okay, so finding the optimum location of that push-pull boundary, it's going to be a little bit of a challenge. So let's look at some of the factors that actually impinge demand uncertainty and economies of scale, and so that it helps us understand what kind of choices that we have to make depending on the current environment that you're operating in. So demand uncertainty. So what happens is that the higher the uncertainty, you do not want to do a push system because you'll stockpile too much inventory in an uncertain environment. So you typically will go with a pull system. And of course, the reverse is also true. Lower the demand, the more you go for a push system. In terms of economies of scale, if economies of scale are quite important, then of course you want to go a push system to produce large quantities, stockpile large quantities. However, if it is not that important to you, you could go with a pull system. All right. So again, those two factors impact what our strategies are. So to determine the optimum location, we have to consider a number of factors like product complexity, manufacturing lead times, and the relationship between the supplier and the manufacturer. Okay. So if you think of where the push-pull boundary is located, there are several ways to actually come up with a decision. Just an example, Dell, for example, locates its push-pull boundary at the assembly point. All right. We have furniture manufacturers located at the production point. In other words, closer to the manufacturer as possible, because while the manufacturer wants economies of scale, the demand is too uncertain. And the cost of these items are fairly large as well. So you would not want to stockpile any of them. So you move that as far back as possible. Okay. If we consider this portable Maya case, and that would be located in a sense, at the manufacturer, who actually does the textile manufacturer, because they will stockpile a lot of the generic items, the fabric, the zippers, and so forth, but they would only then produce when they receive firm orders. All right. So the push portion, let's look at the impact of the push-pull strategy. The push portion, as we've already said, low uncertainty, service level is not an issue. Focus on cost minimization. Sometimes when they have long lead times don't allow you to be responsive, and so one of the ways to actually become responsive is to have stock, and then you ship out of your stock. Complex supply chain structures. And then, of course, we could minimize costs if we better utilize resources such as production and distribution capacities to get economies of scale there. And then we try to find ways to minimize inventory and transportation costs. Okay. The pull portion, however, when we have high uncertainty, a simple supply chain structure that makes it easy to just have the item shipped from the distribution center to the warehouse, to the retailer. If your structure is fairly simple, it's a lot easier to implement a push-pull strategy. The pull portion. Short cycle time. So with short cycle times, then you could react to demand fluctuations much more quickly. Focus on service level. Often high service level requires shorter lead times, and so that's consistent with short cycle times. And then you would achieve that by having what we call a flexible and responsive supply chain. Flexible in the sense that it could adjust to the fluctuations in the level of demand, but it's also responsive in that it has short lead times. Other fulfillment processes are applied. What that means is that part of the efficiency comes from how good or how efficient you are at filling orders. Because without that, it makes it difficult to be responsive. So the differences between push and pull systems, if you look at the objectives, on a push system is minimize costs. On a pull system, we are more concerned about maximizing service level. Complexity tends to be higher with a push system, lower with a pull system. We focus more on allocating resources so we get economies of scale. We focus more on being responsive. We have short lead times here, tends to be longer. And then we have to now focus on, because of the complexity, focus more on supply chain planning. Whereas here, we simply want to fulfill that order as quickly as possible. All right. So the 2 points actually interact via buffer inventory. As I mentioned to you, the buffer inventory now is the output of the push system and is the input into the pull system. So when you have buffer inventory, when you receive an order from a customer, you pull out of that buffer inventory. The push part of your supply chain is what creates that buffer inventory. Okay, so there are different roles for each. In the pull portion, we see here the buffer inventory is part of the output generated, and the pull system is the input. And the interface between the two is the forecasted demand, because it is the forecasted demand that allows the push part of the system to determine what kind of buffer inventory is going to keep. And the pull side, what happened is that the actual demand is supposed to help with pulling inventory out of that buffer stocks. Okay, so the forecast at the interface is quite important. How does lead time actually impact that push-pull boundary? The longer the lead time, so the more important it is to implement a push strategy. So when you look at lead times at different stages, you get a sense of if the manufacturing lead time is long, the manufacturer will want to go with a push. If the wholesaler's lead time is long, etc., etc. But then if the lead times are short, then you could certainly move towards a pull strategy in this case, right? So let's just look at the impact of lead time and what happens. So if demand uncertainty is high, so we're looking at demand uncertainty versus the lead time. Lead time is short and long. So let's look over here at this this point. High demand uncertainty favors pull, and short lead times also favors pull. So this should be a pull system. Long lead times and low demand uncertainty favors push. But across this diagonal, if you have short lead times and the demand is fairly certain, short lead times, then you just do what you call continuous replenishment. So in other words, we know what you're going to require. It's very easy for us to get it there. So we could supply you daily or every 2 days or every 3 days. So we continually replenish your stock. On the other hand, if the demand uncertainty is fairly high and the lead times are also long, we got to position inventory somewhere in the supply chain to try to find ways to reduce the impact of the lead time, but at the same time hedging the risk associated with the uncertainty in demand. So we refer to that as inventory positioning. Where do you position the inventory? So you got to position inventory strategically. And if you recall, HP, in the day when it used to have separate power supplies for 115 and 220, what it would do, it had a postponement strategy where the main part of the printers and the different power supplies were all positioned at a warehouse just before, at the distribution center, sorry. And what happened is within that distribution center, there was a final assembly stage. So the inventory was positioned there. When the order was received, then the section of that distribution center that did the assembly would put the 240 volts in the printers if it was meant for and a location that uses 240 and vice versa. So the inventory was actually positioned at the distribution center. We've already discussed the impact of lead time here. So let's look at demand-driven strategies. What can we do in the context of managing the push-pull boundary from a demand standpoint? Well, remember that the demand forecast is very important because the level of accuracy impacts the bullwhip effect and so forth. So we got to be able to forecast the demand, and in some cases you could actually shape the demand, right? So demand shaping has to do with the kind of promotions and discounts and pricing that you offer. As you could see for Walmart, it's in fact shaping its demand by offering everyday low prices. The demand is such that it's fairly stable, and that's the shaping that it wants. Promotions tend to kind of create spikes, and that might just be in a case where if you have too much inventory sitting in a warehouse, you want to get rid of some of that, particularly if the inventory is about to expire. Then you could find yourself offering discounts so that you could have a spike in demand to get rid of that excess inventory. So that's a form of shaping in that regard, right? So we know that forecast errors, because they're always present, they create challenges for the supply chain. And so attempting to find ways to improve forecast accuracy is an important aspect of managing the supply chain. So whether or not we aggregate forecasts to reduce the effect of the variability, use market analysis, you try to determine what is the optimum assortment of SKUs to keep at each store so that every store doesn't have to carry everything. And then you could use transshipment if an order arrives at a particular store and that store doesn't carry that item, but another store does, it could be transshipped from that store to where the demand has actually occurred. So there are strategies that you try to find to improve forecast accuracy. Okay. A very big part of supply chain coordination and integration has a lot to do with the internet. What has happened with online stores, and when they came into effect, they offered great opportunities, and so a number of companies decided to open online stores. However, a lot of them had some serious issues, largely because the nature of the supply chain to support those was not well understood. With a bricks and mortar sort of operation, it's easy to sort of figure out that you might connect to that facility a bit of a warehouse and then have items shipped down to that warehouse, and then the store is actually fed from that. In the case of an internet business, your customers could come from anywhere. I mean, unlike a bricks and mortar store where it is your demand is localized within a particular radius, but then with the internet, I mean, you can receive orders all over the globe. So what that means is that there are major implications for your supply chain strategy. So a number of companies that started off, Furniture.com, Peapod, they failed. Amazon started off. While it was a success, but Amazon struggled in the beginning because it had huge operating costs, and it made lots of revenues, but then there was serious operating losses until eventually it started to see profits. But behind all of these types of businesses, the supply chain became really, really crucial. And so in e-business, where companies are actually functioning via electronically in terms of the relationships, or you create business models based on the internet, the importance of the supply chain cannot be underscored. E-commerce is just a part of a e-business strategy. So what are some observations? Essentially, while internet technology drove a lot of the change in some of the business models, there needed to be a focus on the supply chain, the back end, to support the business model. So business to consumer models, business to business models, and so on. A lot of those things, if you look at the retail activities, They required, if you think about, say, either, say, Walmart online store and so on, those companies have to coordinate the supply chain so that they could ship to customers in a lot of places. Unfortunately, you cannot get the benefits of full truckloads because customer orders occur in small amounts. And you may actually find yourself having to ship small quantities in several different directions, so you don't get the benefits of economies of scale. So those models have major impact on transportation costs. However, you could get good performance if you use third-party suppliers who are more like couriers, people who handle packages, who specialize in shipment of packages. And so for both business to business and business to consumer operations, that kind of logistics became extremely important. All right. There were some early mistakes that were made with some of the different online businesses. So, for example, in the grocery industry, if you think about it, there's an environment where the push system is actually quite prevalent because of the fact that you have low levels of demand, uncertainty, and the need for large economies of scale. But when people had started out, it decided I was going to focus on a pull strategy and not keep inventory and no facilities per se. So a pull strategy, that is when it gets an order, that is when it would initiate the putting together of the package for the customers. Well, of course, when you do that without distribution centers strategically located based on your customer distribution, it meant that you had to cover a very large geographical area. And in covering a large geographical area, it meant that transportation costs became very, very high. So some of the challenges were, how do you reduce transportation costs? And not only that, if you're covering people over a fairly large geographical area, they want their groceries pretty quickly. If they're going to get their groceries pretty quickly and you have low customer density, that means you're going to have to essentially ship out several times to several different directions and locations, groceries, and that could just drive your transportation costs significantly. And because we know that the grocery business is a low margin business, then that kind of operation was not very effective. Okay. In the book industry, Amazon itself started off as a pull system where it would receive an order and then try to get it shipped directly from the manufacturer. So it used to use Ingram Book to worry about the benefits of inventory pooling. But what happened is that as it grew, inventory did not, Ingram Book Group did not have enough capacity, and Amazon itself realized that it could actually achieve the benefits of inventory pooling itself if it created its own distribution centers, because its demand had to reach a critical mass to allow it to be able to do some consolidation at the various distribution centers and get the benefits of risk pooling and inventory pooling and so forth. So as a result, Amazon decided to establish several warehouses around the country where it kept most of its titles. So in these warehouses, of course, it made sense for Amazon to keep the high velocity items, the ones that are moving pretty quickly. So there's fair amount of demand, and so those items do not remain there too long. However, slower moving items did not need to be stocked at the distribution centers. They could have remained at the suppliers, and then when the demand arrives, then it would trigger an order to those suppliers and have them direct ship to customers. So in a sense, that's a pull part of the operation. But at its own distribution centers for fast moving items, if it stocked most of those items, then that was the push part of the distribution system. So we see both a combination of push and pull. So these companies eventually started to move away from just either strictly push or strictly pull to a combination of push and pull. All right. And then, of course, in the general retail industry, we move from bricks and mortar to clicks and mortar. And in a case like that with the bricks and mortar, you may tend to see a lot more of a push strategy. However, in a clicks and mortar environment, what you tend to have is that if you have high fast volumes that we talk about, fast moving items, those tend to be stocked at the stores because they will go pretty quickly. You don't have to worry about obsolete inventory and so forth, and the inventory being tied up for a while. So that could be handled by a push strategy. However, low volume, slow moving items tend to be stocked centrally, and you use a push pull strategy for that. So you push up to the warehouse or the distribution center, and then you pull out of the distribution center for the slow moving items as they're required. And so traditional fulfillment versus e-fulfillment, let's look at some of the differences. In traditional fulfillment, you tend to see more of a push. In e-fulfillment, a bit of push-pull. Bulk shipment in traditional fulfillment, parcels. And so it means that with a parcel delivery, you need a different kind of distribution system. And in this case, most companies would hire a third-party provider, a third-party logistics provider. Reverse logistics, a small part of the business, whereas important and highly complex part of e-fulfillment, because the transportation costs make up a fairly large chunk. Small number of stores in terms of delivery destination, large number of geographically dispersed customers. Lead times are relatively long, relatively short. So these are some important differences in push-pull systems or traditional versus e-fulfillment systems. So to summarize here, we looked at the issue of integrating the supply chain, and part of that integration requires a decision around where to locate a push-pull boundary. We live in an environment now where information plays a major role and offers some opportunities, so that way it is not always optimal to have a pure push or pure pull system. In some cases, we could actually have a hybrid between those two, and then identify a push-pull strategy where part of the operation functions on a push and the latter part of the operation functions on a pull system. Of course, the decision is not trivial and has to be optimized for each different supply chain.